Hey guys, welcome back. Today, we're diving into one of history's most mind-blowing revelations, the advanced technology of the Roman Empire. We often imagine Rome as chariots, marble statues, and togas. But what if I told you they built machines, materials, and networks so advanced they rival some of what we use today? From self-heating baths to concrete stronger than anything we've made in centuries. The Romans weren't just warriors. They were engineers far ahead of their time. So grab a seat, because today we're uncovering the hidden tech that built an empire. And before we begin, tell me, where are you watching from, and what time is it there right now? The Roman Empire's genius began with its infrastructure. Their roads were marvels of precision, stretching over 250,000 miles, connecting cities, ports, and frontiers, built with multiple layers of stone, gravel, and sand. They were engineered to drain water efficiently, which is why many still exist today. These roads didn't just move armies. They moved information, trade, and ideas across 3 continents, creating one of the first globalized systems in history. Their aqueducts were another technological masterpiece. Using only gravity, they transported fresh water from distant springs and mountains into cities, fountains, and even private homes. The Aqua Appia and Aqua Claudia were so advanced that some Roman aqueducts supplied nearly 300 million gallons of water daily. This innovation powered baths, latrines, and irrigation systems. Inside Roman homes, plumbing systems revealed astonishing sophistication. Lead pipes connected to underground sewers, and public bathhouses used heated floors, an invention called hypocausts. Hot air circulated beneath raised floors and within the walls, keeping rooms comfortably warm during cold seasons. It was, in essence, the world's first central heating system, centuries before the Industrial Revolution. But perhaps the Romans' greatest invention was concrete, a mixture so durable that many modern engineers still study it. Unlike today's concrete, which weakens over time, Roman concrete grows stronger. Made from volcanic ash, lime, and seawater, it chemically reacted with the environment to self-heal cracks. That's why structures like the Pantheon and aqueducts remain standing after nearly 2,000 years. Their military technology also showcased ingenuity. The Romans designed siege weapons such as the ballista and onager, capable of launching stones and bolts with deadly precision. Their legions used portable bridges, battering rams, and even mobile fortifications, tactical designs that influenced warfare for centuries. Every innovation was built for efficiency and control, ensuring Rome's dominance across Europe, Africa, and Asia. Rome's obsession with public health led to an early understanding of sanitation. The Cloaca Maxima, one of the world's first sewer systems, carried waste out of the city and into the Tiber River. Public baths encouraged hygiene and social gathering, and Roman doctors used surgical tools almost identical to modern instruments: scalpels, forceps, and bone drills. Some were made from bronze, others from iron, demonstrating both precision and metallurgy far beyond their era. Then there was architecture, where art met engineering. The Colosseum's retractable awnings, known as the Velarium, could shade over 50,000 spectators. Its complex network of elevators and trapdoors allowed animals and gladiators to appear suddenly from below, an ancient form of stage automation. Even the Pantheon's dome, with its central oculus, remains the largest unreinforced concrete dome in the world. In the realm of transport and communication, Rome's courier system, the Cursus Publicus, rivaled early postal networks. Relay stations allowed messengers to change horses and deliver information swiftly across provinces. Combined with their meticulously mapped roads, messages could travel thousands of miles faster than any other ancient civilization. And let's not forget engineering for leisure. The Romans built amphitheaters, racetracks, and even rotating dining rooms powered by slave labor and water flow. Yes, Emperor Nero's palace, the Domus Aurea, had a dining room that spun like a planetarium. They engineered sound amplification in theaters, designed marble cooling systems in banquet halls, and used bronze mirrors to reflect candlelight like early light fixtures. Even agriculture and industry benefited from Roman innovation. Water mills ground grain using hydropower, and vineyards used mechanical presses. The Romans developed complex mining techniques, channeling water to break apart rock, a method known as hushing. Their workshops produced glass, bronze, and textiles in mass quantities, turning Rome into an ancient industrial powerhouse. What's truly remarkable is how much of this knowledge vanished after the empire fell. For centuries, the secrets of Roman concrete, heating, and hydraulic systems were lost to time. Only recently have scientists begun to rediscover how they worked, proving that the Romans' understanding of chemistry, physics, and design was generations ahead of their peers. The legacy of Roman technology endures in modern architecture, road construction, and even city planning. Every modern highway, aqueduct, and building owes something to Roman ingenuity. Their vision wasn't just to build for today, it was to build for eternity. And in that, they succeeded more than any civilization before or after. Would you have guessed that the ancient Romans were this advanced? It's mind-blowing to think how much of our modern world stands on the shoulders of their genius. The Roman Empire wasn't just a civilization, it was a living machine. Every stone, pipe, and pillar served a purpose. What set the Romans apart wasn't just conquest, but the meticulous way they used engineering to control nature itself. Whether it was moving mountains for roads or bending rivers to feed their cities, Roman technology turned the impossible into everyday life. At the heart of this empire's success was logistical precision. Roman engineers were trained not only as builders, but as mathematicians and surveyors. They used tools like the Corybates, a leveling instrument, and gramma, a surveying cross, to map straight lines over vast, uneven terrain. These devices allowed them to construct roads and aqueducts with gradients so precise that even modern engineers marvel at their accuracy. Some Roman roads deviated less than a meter across tens of kilometers, an extraordinary feat with the tools of their time. Their urban planning also revealed a systematic brilliance. Every Roman city was designed around a central forum, with streets laid in a perfect grid pattern. The Cardo Maximus and Decumanus Maximus, the main north-south and east-west roads, divided cities with mathematical precision. This layout ensured efficient movement, ventilation, and access to markets and temples. Many European cities today, from Cologne to Barcelona, still follow the grid design first introduced by Roman architects nearly 2 millennia ago. Water, however, was the true lifeblood of Rome's technology. Without it, the empire would have collapsed. The aqueducts were not simply stone channels, they were a symphony of physics and architecture. Engineers calculated slopes so gentle that water would flow smoothly across valleys and hills, without bursting pipes or losing pressure. When obstacles arose, they built towering arcades that spanned miles, elegant yet durable structures that stood against earthquakes and floods. The Pont du Gard in France and the Aqua Virgo in Rome remain perfect examples of their hydraulic genius. The water's journey didn't end at the aqueduct. Once inside the city, it split into a vast distribution network. Lead and terracotta pipes channeled it into fountains, public baths, and private estates. Engineers even installed control valves and inspection hatches, a concept that wouldn't reappear in Europe until the 18th century. Clean water meant not just hygiene, but luxury. Wealthy Romans could enjoy indoor plumbing, private fountains, and bathing rooms with running water, amenities nearly unmatched until the modern age. When it came to heating, Roman innovation bordered on futuristic. The hypocaust system, developed during the early empire, was a revolution in comfort. Beneath the stone floors, small brick pillars created a crawl space through which hot air flowed from a nearby furnace. Warmth radiated upward, heating the rooms above. Wealthier homes even had adjustable systems where air could be directed through hollow walls. It was central heating in the truest sense, efficient, elegant, and sustainable. Archaeologists have found remains of these systems from Britain to North Africa, proof that Rome's warmth spread across continents. Equally fascinating was their mastery of materials science. Roman builders experimented endlessly with combinations of volcanic ash, lime, and rock to produce what became known as opus caementissime, or Roman concrete. Unlike modern cement, which deteriorates with moisture and salt, Roman concrete chemically interacts with seawater, forming new minerals that strengthen over time. Marine structures, like the harbor at Cosa or Portus Claudius, still resist erosion today, baffling modern engineers. Recent studies have found that Roman concrete can even heal cracks naturally through reactivation of lime pockets, a form of self-repair centuries ahead of its time. Their metalworking industry also displayed remarkable sophistication. Romans extracted metals like iron, copper, and lead on an industrial scale using water-powered hammers and smelting furnaces. They forged tools, weapons, and even surgical instruments with extraordinary precision. The use of steel, rare in the ancient world, was documented in Roman armories, where blades like the Gladius Hispaniensis were crafted with techniques resembling early pattern welding. The craftsmanship of Roman metalworkers became legendary, influencing medieval blacksmiths for centuries afterward. Roman innovation extended far beyond construction and warfare. It shaped everyday life. Consider the Roman baths, massive complexes that blended architecture, plumbing, and social culture. These baths featured warm, cold, and hot rooms, each regulated by complex heating systems. Some even included steam chambers and cooling pools. Engineers managed temperature by adjusting furnace airflow, much like modern thermostats. These spaces weren't just for cleaning. They were centers of community, relaxation, and even business negotiations. The Cloaca Maxima, Rome's great sewer system, demonstrated their obsession with cleanliness and order. Built initially in the 6th century BCE, it evolved into a sprawling underground network that drained wastewater and rainwater alike. It used gravity-driven flow, stone vaulting, and inspection chambers, innovations that reappeared in modern sewer engineering almost 2 millennia later. The fact that sections of it are still functional today is a testament to its enduring design. In military logistics, the Romans' engineering discipline reached its peak. Every legion traveled with surveyors and engineers who built bridges, camps, and roads in record time. The Pons Fabricius, built in 62 BCE, is the oldest Roman bridge still in use, proof that their structures weren't temporary feats, but built for generations. Portable bridges could be assembled in hours, and siege weapons were transported on modular carts. Rome's ability to move its armies efficiently wasn't just tactical brilliance, it was mechanical science. The amphitheaters and stadiums were also triumphs of design and innovation. The Colosseum, completed in 80 CE, featured a complex network of pulleys, ramps, and trapdoors that allowed gladiators, wild beasts, and stage props to emerge from below. Beneath its wooden floor lay a labyrinth of rooms and mechanical lifts, a true marvel of ancient stage engineering. Its velarium, a vast retractable awning operated by sailors, shielded tens of thousands of spectators from the sun. The combination of architecture and mechanics was centuries ahead of its time. The Romans also mastered glassmaking and optics, a lesser-known aspect of their technological prowess. They pioneered the use of transparent glass windows, something no other ancient civilization achieved on such a scale. They blew glass into molds, cut it, and even experimented with magnification through convex lenses. Fragments found in Pompeii show that Roman households used colored glass mosaics and transparent panes to manipulate light within rooms. Early experiments in architectural lighting. One of the most overlooked but profound Roman technologies was timekeeping. They built sundials so accurate that they accounted for seasonal solar shifts. In the later empire, water clocks or clepsydra were refined to measure hours during the night, an advancement that allowed cities and militaries to synchronize activities. Some Roman clocks even featured gears and valves, mechanical foundations that prefigured later clockmaking in the Islamic Golden Age and medieval Europe. Their mastery of transportation was not limited to roads. Roman shipbuilders designed vessels capable of carrying hundreds of tons of cargo. They developed watertight compartments, double hulls, and sophisticated anchor systems. The Nemi ships of Emperor Caligula were floating palaces with marble floors, plumbing, and even rotating statues, clear evidence that Roman naval architecture approached an early form of maritime luxury engineering. What's most striking, perhaps, is the philosophical unity behind all this technology. Romans believed in utilitas, the idea that every invention must serve a practical, lasting purpose. This mindset, paired with their unparalleled organizational skill, created an empire where science and function blended seamlessly. Whether laying bricks or mapping stars, the Romans approached their world with curiosity, precision, and an unshakable will to improve upon it. Their influence remains etched, not just in ruins, but in the DNA of modern civilization. Every aqueduct-inspired dam, every concrete bridge, every heated home carries a trace of Roman genius. Even our legal, architectural, and military systems echo their logic. The Romans didn't just inherit the ancient world, they redesigned it, and in doing so, they laid the foundation for nearly everything that came after. To truly understand the brilliance of Roman technology, one must look beyond the grand monuments and into the subtler systems that made the empire's daily life function. Beneath every triumphal arch, every marble villa, and every distant outpost was a hidden network of infrastructure, designed with mathematical foresight and precision. Rome was more than an empire of armies, it was an empire of engineers. Their road network, stretching over 400,000 kilometers at its peak, was a marvel of layered construction. Each road was composed of several strata, a compacted foundation of stones and gravel, a middle layer for drainage, and a top surface of polygonal basalt slabs that fit together like a puzzle. The precision of this system allowed for durability so remarkable that remnants of Roman roads still carry traffic in Europe today. These roads weren't just pathways. They were lifelines connecting legions, merchants, and messengers from Britain to Mesopotamia. They were the nervous system of an empire that never slept. What many overlook is how Romans applied scientific thinking to every stage of construction. They calculated curvature to allow water runoff, aligned highways using celestial observations, and standardized milestones to measure distance across continents. The consistency of Roman road markers even allowed later medieval travelers to navigate centuries after the empire's fall. Each milestone carried not just a number, but the emperor's name, a subtle reminder that the empire's authority extended into every stone beneath one's feet. Even more astonishing was the Roman mastery of hydraulic engineering. While the aqueducts often steal the spotlight, their water mills were equally revolutionary. Archaeologists at Barbigale in southern France uncovered a complex of 16 interconnected water wheels, the world's first industrial-scale factory. These mills could grind enough grain to feed tens of thousands daily, all powered by controlled water flow. The Romans had effectively built the earliest known mechanized production system nearly 1,700 years before the Industrial Revolution. The Romans also harnessed geothermal energy long before the term existed. In areas like Baiae, near Naples, natural hot springs were redirected through pipes and chambers to heat bathhouses. Wealthy estates tapped volcanic steam vents for heating and cooking, transforming raw elements of the earth into tools of comfort. Their understanding of geothermal pressure and heat management foreshadowed technologies that wouldn't reappear until the 19th century. Another innovation often forgotten is Roman surveying, the quiet science that enabled every triumph in architecture and mapping. Engineers used instruments like the dioptra, an ancestor of the modern theodolite, to measure angles and elevations. With these tools, they could plot city layouts, aqueduct routes, and even drainage systems with mathematical precision. Some Roman maps, like the Tabula Putensiria, covered thousands of kilometers with such accuracy that they continued to influence cartography deep into the Renaissance. But Roman genius wasn't confined to static structures. It extended into mechanical automation. Ancient texts by Hero of Alexandria, a Roman-era engineer, describe intricate machines powered by steam, air pressure, and pulleys. Among his creations were self-opening temple doors, coin-operated machines that dispensed holy water, and even an early prototype of the steam turbine known as the eolipile. Though used mainly for spectacle, these inventions proved that Romans had already glimpsed the potential of automated power, centuries before industrial engines would change the world. In the realm of medicine, Roman innovation blended practical engineering with anatomical insight. Hospitals, or valetudinaria, were systematically designed with ventilation, sanitation, and running water. Roman surgeons employed bronze and iron instruments so advanced that modern counterparts still mirror their designs: scalpels, forceps, and bone saws. Even battlefield medics operated with sterilization methods, using vinegar and boiling water. Centuries before germ theory was understood, their surgical tools and organized hospitals laid the groundwork for modern military medicine. Roman architecture itself was a dialogue between beauty and function. The arches that defined their buildings were more than decorative. They distributed weight evenly, allowing for vast open spaces without collapsing walls. Domes, like that of the Pantheon, demonstrated their mastery of tension and compression. The oculus at the Pantheon's peak wasn't merely symbolic. It reduced the dome's weight, while allowing sunlight to illuminate the interior in perfect alignment with the building's geometry. Modern architects still study its proportions as an eternal lesson in balance and harmony. Their heating systems, too, went beyond comfort. They reflected an understanding of thermodynamics far ahead of their time. The hypocaust, when used in public baths, required constant temperature regulation. Engineers achieved this by creating a draft effect, drawing in cold air through vents and pushing hot air through flues embedded in walls and floors. The system was so efficient that entire bath complexes could maintain multiple temperature zones. It was not just heating, it was climate control, centuries before thermostats existed. Even agriculture, often ignored in discussions of Roman technology, was transformed by mechanical and hydraulic tools. The Romans developed the vallus, a reaping machine drawn by animals that could cut crops more efficiently than manual labor. Water-lifting devices, like the Noria and Archimedes' screw, were adapted for irrigation, ensuring steady food supply across dry provinces. These tools didn't just improve productivity, they reshaped the empire's ability to sustain itself over vast territories and harsh climates. Roman communication systems were another marvel. The cursus publicis, established by Augustus, was a state-run postal and courier network supported by relay stations every few miles. Couriers could carry messages across the empire in days, not weeks, thanks to standardized roads and rest stops equipped with fresh horses. This system became the logistical backbone of Roman governance, a form of bureaucratic internet that kept distant provinces tied to the capital's will. Even their entertainment technology revealed advanced mechanical understanding. The Naumachia vast arenas flooded two-stage naval battles, demonstrated water control on an epic scale. Engineers built underground channels and sluice gates to fill and drain these artificial lakes rapidly. It wasn't merely spectacle. It was proof that Roman hydrology was both scientific and theatrical. Their amphitheaters, theaters, and circuses all featured acoustic innovations, sound-reflecting walls, tiered seating, and calculated dimensions that amplified voices without modern amplification. The Roman scientific mindset is perhaps best seen in their written works. Thinkers like Vitruvius recorded detailed architectural treatises that blended mathematics, physics, and aesthetics. His De Architectura emphasized proportion, stability, and human-centered design, principles still taught in architectural schools today. This written preservation of engineering knowledge ensured that even after Rome's fall, its ideas survived, influencing Islamic engineers, Renaissance thinkers, and modern architects alike. Perhaps the most understated innovation of all was standardization. Every Roman workshop, foundry, and legion followed unified specifications for tools, weapons, and building materials. The size of bricks, the diameter of pipes, even the width of wagon wheels, all were standardized to ensure compatibility across the empire. This consistency wasn't just administrative. It was a technological philosophy that prefigured industrial manufacturing by more than 1,000 years. Even in death, Romans engineered permanence. Their tombs and mausoleums, from the modest columbarium to the colossal mausoleum of Hadrian, were feats of endurance and symmetry. They employed concrete cores, marble facades, and geometric layouts aligned with celestial points, merging art, religion, and geometry in one seamless design. The same attention to structure that raised aqueducts and amphitheaters also shaped the architecture of memory itself. In essence, the technology of the Roman Empire wasn't merely a collection of inventions, it was a culture of innovation. It thrived on order, measurement, and experimentation, from the humblest clay pipe to the grandest dome. Every artifact spoke of a civilization that believed mastery of the physical world was a reflection of divine harmony. The Romans didn't just build for their time, they built for eternity. And, remarkably, eternity has kept their secret well. From the quiet hum of a restored watermill to the enduring shadow of the Colosseum, Rome's inventions still whisper across the centuries, reminding us that the foundations of our modern world were first laid in the dust and marble of an ancient one. The secret behind Rome's technological supremacy lay not merely in invention, but in integration. Unlike the Greeks, who often separated science from practicality, the Romans wove knowledge directly into daily function. Their architects, engineers, and artisans worked side by side with soldiers and administrators, ensuring that innovation was never confined to theory. It was this blend of utility and ambition that turned modest ideas into systems that defined an era. Consider the construction of aqueducts, the arteries of Roman civilization. These vast structures weren't simply elevated channels of stone. They represented the pinnacle of Roman civil planning. Each aqueduct was designed to maintain a constant gradient, often no steeper than a few centimeters per kilometer. This precision allowed water to travel hundreds of miles solely by gravity, sustaining cities with populations that rival modern metropolises. Towns that once suffered drought became lush with public fountains, baths, and gardens, all because of a delicate balance of physics and stone. The true brilliance of these systems lay underground. Engineers designed inspection shafts, settling tanks, and maintenance tunnels to ensure water quality. Lime sediment was periodically removed using specialized tools, and valves were used to control pressure, an astonishing level of foresight for an era without pressure gauges or modern materials. Some aqueducts, like the Aqua Claudia, operated continuously for over 4 centuries, an engineering record that modern infrastructure rarely matches. The Romans also understood the psychology of power through architecture. They knew that technology could be propaganda. When citizens saw massive aqueduct arches slicing across valleys, or walked beneath the vaulted ceilings of basilicas and baths, they weren't just admiring beauty, they were witnessing the empire's mastery over nature, the ability to control water, temperature, and even sound became a visual metaphor for control itself. Every brick was a political message. Behind this grandeur, however, stood armies of anonymous engineers and laborers, whose skill kept Rome alive. Quarrymen selected and cut stones by hand, using wooden wedges soaked in water to split marble precisely. Surveyors plotted routes across mountains with basic tools like the groma, yet achieved near-perfect alignment over hundreds of miles. Blacksmiths, potters, and carpenters collaborated across disciplines. The empire's technological machine ran on both intelligence and sweat. The Roman obsession with urban planning also revealed their systematic mind. Towns were not built haphazardly. They followed a grid plan centered on the forum, surrounded by baths, temples, markets, and housing. Streets were laid out to catch the prevailing wind and maximize airflow. Even sewage systems were integrated into this order. The Cloaca Maxima, Rome's great sewer, was not only a sanitation marvel, but an ecological one. It redirected waste into the Tiber, preventing disease outbreaks and floods. For centuries, it remained in use, its tunnels so well built that they still handle stormwater today. Roman materials science remains perhaps their most astonishing achievement. Their concrete opus cementitium was mixed using volcanic ash, lime, and seawater. Modern scientists have discovered that this mixture caused a rare chemical reaction, the creation of crystals that could heal cracks when exposed to moisture. This self-healing concrete, long thought to be a myth, is now being reverse-engineered by contemporary engineers who recognize its potential to revolutionize sustainable construction. The Romans didn't just build to last decades, they built for millennia. And yet, Roman technology wasn't purely utilitarian, it was aesthetic as well. Their architects designed with the Vitruvian triad, Firmitas strength, Utilitas function, and Venustas beauty. This philosophy demanded that every structure, from a temple to a bathhouse, be both useful and pleasing to the eye. The result was a civilization that blurred the line between art and engineering. Columns were proportioned according to mathematical ratios, mosaics reflected geometric harmony, and public spaces were designed to uplift both body and spirit. In the public baths, vast complexes, like the baths of Heracleion, the mastery of Roman engineering reached its cultural peak. These weren't mere bathing facilities. They were social hubs, libraries, gyms, and sanctuaries of relaxation. Beneath the marble floors, the hypocaust system circulated warm air, creating a uniform climate that could shift from hot to cool across chambers. Copper cauldrons, heated by roaring furnaces, kept the system running continuously. To stand in a Roman bath was to stand in a feat of invisible machinery, a place where comfort became technology's ultimate triumph. Even in entertainment, the Romans displayed a kind of mechanical audacity. The Colosseum, capable of seating over 50,000 people, featured a complex network of trapdoors, elevators, and pulleys that could raise gladiators, animals, and stage props into the arena with precision timing. Engineers used counterweights and winches, operated by teams of slaves, to create seamless performances that left spectators in awe. Some accounts even describe the arena being flooded for mock naval battles, a feat requiring meticulous hydraulic planning. The Romans were also masters of sound and space. In amphitheaters, architects calculated curvature and material texture to reflect and amplify voices naturally. In the theater of Pompey or the Odeon of Herodotus Atticus, even the faintest whisper could reach the farthest seat. This level of acoustic sophistication, achieved without electronic tools, would not be replicated until the modern era of concert hall design. Another lesser-known marvel of Roman technology was their early experimentation with mechanical devices. Hero of Alexandria's writings describe automatic doors operated by heat and air pressure, primitive precursors to modern automation. He even designed an early vending machine that dispensed holy water when a coin was inserted, though used mainly for temples and festivals. Such devices demonstrated a curiosity about how nature's forces, heat, air, and water, could be harnessed for human use. Roman naval engineering deserves its own chapter in the story of their technological might. Their warships, particularly the triremes and quinquiremes, were precision-built machines. The Navy utilized complex pulley systems for maneuvering sails and oars, while harbor construction introduced the world's first use of underwater concrete, made possible by volcanic ash that could set in wet conditions. This single innovation allowed Rome to dominate the Mediterranean by building ports and breakwaters wherever expansion demanded. Equally fascinating was their logistical genius. The Romans maintained massive supply chains, transporting grain from Egypt, olive oil from Hispania, and marble from Greece to all corners of the empire. Specialized ships, known as navis honoraria, were constructed to carry heavy cargo efficiently across long distances. Amphorae were standardized for volume, labeled with the producer's name and date, a precursor to modern branding and packaging. In many ways, the Roman economy operated on principles similar to globalized trade today. Even Roman warfare was deeply technological. Legionaries carried standardized equipment, glady short swords, pila javelins, and scuda shields, designed for maximum efficiency and uniformity. Siege engineers built complex weapons like ballistae and onagers with remarkable accuracy. The corvus, a boarding bridge with a spike, allowed Roman soldiers to turn naval battles into hand-to-hand combat, turning the sea into an extension of the battlefield. Every innovation in war reinforced the empire's engineering ethos to control chaos through design. The secret to Rome's resilience lay in its invisible networks. Postal systems carried imperial decrees across continents. Fire brigades patrolled crowded cities. Lighthouses guided ships across perilous waters. The empire wasn't just a map, it was a machine, calibrated by mathematics and maintained by human discipline. By the 1st century CE, the Roman Empire had become what no civilization before had achieved, a fully mechanized society powered by geometry, gravity, and genius. From the aqueducts whispering over hills to the hidden gears beneath the Colosseum floor, the hum of Roman technology was the heartbeat of a world that believed perfection was measurable and eternal. And as the sun set over the domes of Rome, casting gold light on stone and water, one could almost hear that heartbeat still. the rhythm of an empire that refused to be forgotten. For centuries, much of Rome's technological brilliance lay buried not only beneath layers of soil and ruins, but beneath the assumptions of later civilizations that believed progress moved only forward. Yet, as modern science peels back the layers of time, archaeologists and engineers have begun to realize something astonishing. Many of the technologies we think of as modern were, in fact, born under the shadow of Roman arches. Take Roman concrete, for instance, that humble gray material that built empires. For hundreds of years after the fall of Rome, builders tried and failed to reproduce its longevity. Medieval cathedrals crumbled, Renaissance bridges needed constant repair, and modern concrete, despite its strength, often cracks and decays within a century. But recent studies, particularly those conducted at MIT and the University of Utah, have revealed that Roman builders deliberately added limeclasts, or quicklime fragments, into their mixtures. When exposed to water, these clasts triggered a chemical reaction that healed cracks naturally. In other words, Roman concrete was self-repairing. What was once dismissed as poor mixing was actually a deliberate form of ancient nanotechnology. The rediscovery didn't stop there. Scientists analyzing samples from harbors like Pozzuoli and Ostia found that the Romans' volcanic ash, pozzolana, reacted with seawater to form a rare mineral called altobermarite, which strengthened over time. Instead of eroding, Roman marine concrete actually grew harder with age. Modern engineers are now studying this process to design eco-friendly marine infrastructure capable of lasting thousands of years. It seems that the empire's builders didn't merely construct monuments, they created materials that could outlive empires themselves. Then there were the hypocaust systems, Rome's underfloor heating networks. These ingenious designs used flues and hollow bricks to circulate hot air beneath floors and behind walls, maintaining stable indoor temperatures even in massive bathhouses. For a long time, historians viewed them as primitive precursors to modern heating. But new thermodynamic analyses have revealed that Roman architects precisely calculated airflow and heat retention based on room size, wall thickness, and material density. Their mastery of heat transfer physics, achieved with no digital tools or scientific instruments, was astonishingly advanced. In a sense, they built the first central heating systems, thousands of years before electricity or radiators. In the city of Pompeii, ongoing excavations have revealed even more: bronze valves, terracotta pipes, and water pressure regulators embedded within walls. These were components of early hydraulic networks, allowing fountains, baths, and private homes to receive running water with adjustable flow, a concept strikingly similar to modern plumbing. Roman engineers had discovered ways to control and distribute water pressure centuries before the modern era of hydraulics began. Another rediscovered marvel is the Roman road-building technique. While the remains of their roads have long been visible, modern ground-penetrating radar and soil analysis have uncovered why they lasted so long. Beneath the stone paving, Romans used a multi-layered system of gravel, sand, and crushed stone, each layer carefully angled to ensure drainage. Roads were crowned in the center, directing rainwater toward side ditches. This self-draining design prevented erosion, allowing many Roman roads to remain intact after 2,000 years. The methodology is now being studied by civil engineers, developing climate-resilient highways in regions vulnerable to flooding. Perhaps one of the most overlooked rediscoveries lies in Roman mechanical engineering. Ancient texts, particularly those of Hero of Alexandria and Vitruvius, describe inventions that once seemed fantastical: automatic doors, coin-operated machines, even primitive steam-powered devices. For centuries, scholars thought these were mere curiosities. But archaeological finds from workshops in Alexandria and Antioch have confirmed the existence of intricate gears, pressure valves, and rotary mechanisms. Some of these designs resemble the Antikythera mechanism, the famous Greek analog computer, suggesting a shared technological tradition that Rome absorbed and expanded upon. One especially intriguing device, recently reconstructed by researchers, is the hydraulic organ, or hydraulis. Using water pressure and airflow, the Romans created a musical instrument capable of producing complex melodies. The mechanism involved a sealed air chamber regulated by a water tank, an elegant balance of physics and artistry. These instruments were so advanced that some reconstructions are now playable in modern concerts, producing sounds eerily similar to modern pipe organs. Roman optical technology also held surprises. In 2017, archaeologists examining a collection of glassware from the 1st century CE discovered lenses with concave and convex curvatures nearly identical to those used in later microscopes and telescopes. While there's no direct evidence of Roman telescopic observation, it's clear that their glassmakers understood light refraction and magnification. Some suggest these lenses were used in surgical tools or for fine engraving, revealing a subtle scientific curiosity that extended far beyond architecture. Modern science has also reawakened Rome's fascination with environmental control. In places like the Domus Aurea Nero's opulent palace, engineers have found evidence of rotating ceilings and movable panels designed to regulate sunlight and airflow. These weren't mere luxuries. They demonstrated an understanding of passive cooling and climate design, concepts we now call green architecture. The same principles used in Roman villas, cross-ventilation, shaded courtyards, and thermal mass, are being reintroduced in sustainable building design today. And then there's the mystery of Roman metallurgy. Blacksmiths and artisans mastered the art of producing steel that resisted rust better than most medieval equivalents. Recent metallurgical analyses of Roman swords and tools reveal traces of carbon infusion, indicating they may have independently discovered forms of carbon steel long before it was formally invented. Inscriptions on certain weapon fragments suggest a standardized process, hinting that the Romans may have had state-run metallurgical guilds, ensuring consistent quality for their legions. Even Roman timekeeping and mechanics are being rediscovered through fragments once overlooked. The discovery of the Londinium water clock, an intricately carved timepiece found in the remains of Roman London, revealed that engineers used adjustable flow rates to measure time more accurately than any earlier civilization. Combined with sundials and celestial charts, Rome's timekeeping technology bridged astronomy and engineering, regulating everything from religious rituals to military operations. But perhaps the most extraordinary rediscovery lies not in their machines, but in their philosophy of technology. The Romans did not invent for invention's sake. Every innovation served order, control, and endurance. Their technologies were designed not to dazzle, but to last, a mindset that modern civilization, obsessed with novelty, often forgets. As modern researchers decode their forgotten formulas and blueprints, they are uncovering not just ancient devices, but an entire worldview, one that understood that true progress is not measured in speed or spectacle, but in time's endurance. Archaeologists now call this process technorchaeology, the science of reconstructing ancient technology through both excavation and replication. Laboratories across Europe and the United States are recreating Roman materials, testing their limits, and finding that even with today's tools, it's difficult to surpass them. In a remarkable experiment, a team in Switzerland rebuilt a section of aqueduct using only Roman tools and techniques, and found that their measurements matched within millimeters of laser-calibrated accuracy. What emerges from these rediscoveries is a striking paradox. We have not surpassed the Romans in every field. We are, in many ways, returning to them. Their innovations in materials, infrastructure, and environmental design mirror the very challenges we face today: sustainability, durability, and efficiency. The wisdom buried beneath Roman ruins is no longer just archaeological. It is urgently modern. So as satellites scan buried aqueducts and drones map forgotten roads, what we are truly uncovering is not just the history of an empire, but a mirror of ourselves. The Romans may be gone, but their technology, reborn through science, is once again shaping the world. When archaeologists began excavating beneath Rome's Forum and Ostia Antica, they expected ruins, not laboratories. Yet what they uncovered in layers of ash and sediment resembled the remnants of an empire that treated engineering as both art and experiment. Fragments of bronze fittings, lead piping, and calibrated measuring rods revealed that Roman builders worked with precision instruments that would not be reinvented until the Renaissance. The empire's greatness, it turns out, was not just its armies, it was its obsession with measurement. Among the most astonishing finds in recent decades are the Roman surveying tools, particularly the gramma and chorobates. Modern experiments using reconstructed versions have shown that Roman surveyors could measure gradients and align roads with sub-centimeter accuracy, all without lenses or telescopes. With only plumb lines and water levels, they laid out thousands of kilometers of straight roads, aqueducts, and fortifications. This rediscovered skill of geometrical surveying has inspired a reevaluation of Roman engineering. It was not intuition, but methodical science, rooted in observation and mathematics. Meanwhile, new excavations in Baalbek, Leptis Magna, and Ephesus have revealed another marvel: the Roman mastery of massive stone transport. The temples and theaters of these cities contain blocks weighing hundreds of tons, cut and placed with seamless precision. For centuries, it was assumed that slaves and brute force achieved this, but modern studies have uncovered remnants of complex lifting systems. Wooden cranes equipped with multiple pulleys, counterweights, and capstans allowed a handful of workers to lift blocks that would challenge even modern cranes. Experimental archaeology conducted in France and Germany has successfully reconstructed these devices, confirming that Rome possessed a form of mechanical advantage engineering unmatched until the Industrial Age. Recent discoveries have also reshaped our understanding of Roman glassmaking. What was once thought to be crude artisan craft is now recognized as early chemical mastery. Analysis of glass fragments from workshops in Cologne and Alexandria shows that Roman artisans manipulated sand, soda, and lime at controlled temperatures to achieve clarity and color, even adding trace elements like manganese and antimony to prevent discoloration. In some samples, scientists found isotopic fingerprints suggesting intentional recycling of old glass, a clear sign of a circular economy. The Romans were, in effect, early pioneers of industrial material sustainability. And then there's the matter of Roman medicine and surgical technology, long overshadowed by their military achievements. Excavations at Pompey's House of the Surgeon and military hospitals along the Rhine have uncovered scalpels, forceps, bone saws, and even hollow needles made from bronze tools, astonishingly similar in form to modern surgical instruments. X-ray scans reveal that these implements were forged with tempered edges for precision cutting, showing not just craftsmanship but anatomical understanding. Medical historians now believe that Roman surgeons performed cataract removal, dental reconstruction, and cranial surgery centuries before such operations reappeared in Europe. Their blend of metallurgy and medicine is one of Rome's most underappreciated scientific legacies. Modern chemistry has also shed new light on the Romans' textile and dye industries. The legendary Tyrian purple dye, once reserved for emperors, was produced through a laborious chemical extraction from sea snails. Recent laboratory reproductions have confirmed the Romans' ability to manipulate pH, sunlight exposure, and fermentation duration to achieve stable, vivid hues, techniques that rival 19th century industrial chemistry. Ancient recipes, recorded by Pliny the Elder, once dismissed as mythic exaggerations, now read like coded formulas for organic synthesis. In architecture, rediscovered inscriptions and models suggest that Roman architects experimented with scale models and structural simulations long before computer-aided design. Clay models found at Vindolanda show small-scale arches, dome segments, and column stress tests, physical prototypes for testing weight distribution. It appears Roman engineers understood something close to the modern principle of load testing, creating miniature versions of bridges and domes before committing to full-scale construction. Equally fascinating is the rediscovery of Rome's geothermal and hydropower usage. At sites such as Aquisules, modern Bath, England, and Bye, engineers have found evidence of geothermal channels redirecting natural hot springs into bath complexes and villas. In several locations, remnants of millstones and water wheels powered by diverted streams indicate early forms of mechanical automation. Water-driven mills that ground grain, sawed wood, and even operated mining equipment. A Roman poet once described a mill that sings to the rhythm of falling water, and now archaeological evidence supports this poetic truth. The Romans' understanding of acoustics also re-emerges through modern studies of their amphitheaters. At the Odeon of Lyon and Verona's Arena, scientists using acoustic mapping technology discovered that Roman architects deliberately shaped their theaters to reflect sound evenly to the top rows. They used limestones, reflective surfaces, curved seating, and open corridors to amplify voices without any amplification devices. The precision is so exact that modern sound engineers now study Roman theater design for insights into passive acoustic architecture. Even Rome's military technology, often reduced to stories of discipline and tactics, is being reinterpreted through forensic archaeology. Excavations in Britain and Dacia have revealed modular construction kits for field forts, prefabricated wooden towers, standardized tent pegs, and collapsible bridges. The legions, it turns out, operated like mobile engineering corps, capable of building fully functional bases in less than a day. The same efficiency that built empires also gave Rome one of history's earliest examples of standardized mass production. Roman lighting technology deserves mention too. Bronze and clay lamps with adjustable wicks and mirrored interiors have been found in domestic spaces and tunnels, including the catacombs of Rome. Analysis of soot residues shows that Roman artisans used purified olive oil and added salt to stabilize flames and reduce smoke, an early form of clean-burning fuel technology. In deeper tunnels, such as those beneath Naples, archaeologists discovered networks of reflective panels effectively acting as ancient light guides. The more modern science unearths, the more it becomes clear that Roman innovation was not a patchwork of genius moments. It was a sustained culture of experimentation. Behind every aqueduct or bathhouse was a workshop where artisans, builders, and scholars collaborated. The empire's engineers didn't just build things, they documented, refined, and replicated. Their manuals, from Vitruvius to Frontinus, read like proto-engineering textbooks, blending observation, mathematics, and practical application. What makes these rediscoveries even more striking is how much of this knowledge nearly vanished. After the empire's collapse, centuries of progress unraveled. The secrets of Roman cement, metallurgy, and mechanics were lost, buried in texts few could read. Only now, with advanced imaging, chemical analysis, and digital reconstruction, are we beginning to rebuild their brilliance, brick by brick, formula by formula. In laboratories and museums today, this revival continues. 3D scanners map Roman aqueducts with millimeter precision. Chemical engineers test ancient pigments under microscopes, and roboticists study Roman machines for insights into mechanical balance. The empire that once spanned continents now spans centuries, its technology reawakening in modern form. Rome's lost inventions were not failures of memory. They were lessons in longevity, waiting for a world advanced enough to understand them again. If one walks today through the ruins of Ostia Antica or Herculaneum, it's easy to mistake the crumbling stone for silence. Yet beneath that silence lies a dialogue between the ancient world and the modern one that continues to grow louder as science deciphers the empire's forgotten codes. Among the most remarkable rediscoveries of recent decades is the Romans' use of self-healing materials beyond concrete. Excavations at Cosa and Puteoli have revealed ancient coatings and mortar that contain naturally forming crystalline layers. When exposed to moisture, these layers bloom again, sealing microcracks. Modern material scientists studying these samples have confirmed what ancient builders somehow understood instinctively, that certain lime-pozzolana ratios allow for chemical reactivation long after setting. This technology wasn't just advanced, it was sustainable in a way that even today's cement struggles to match. Equally ahead of its time was the Roman mastery of hydraulic engineering. The sprawling aqueduct system that once fed Rome's baths, fountains, and households didn't merely rely on gravity. It was optimized through pressure control, siphons, and distribution towers. Excavations in Lion Lugdunum and Segovia have unearthed sealed lead pipes with carefully engineered joints and flow restrictors, proving the Romans could regulate water flow with surprising accuracy. Studies using ground-penetrating radar have even revealed multi-tiered pipe systems, indicating early experiments in water zoning, separating potable water from industrial channels, a level of urban planning centuries ahead of its time. Another rediscovered marvel lies in the thermal engineering of Roman baths. At first glance, the hypocaust system, a raised floor heated by hot air from furnaces, seems simple. Yet thermal imaging and computational modeling have shown the sophistication of its design. The Romans used curved flues to circulate air evenly, reducing temperature gradients and improving fuel efficiency. At Bath, Aquisales, and Trier, restorations demonstrate that these systems maintained stable indoor climates even in cold winters. Some archaeologists now refer to this as the earliest form of central heating, proving once again that comfort, not just survival, was a Roman art. And then there is the Naumachia, the Roman mock sea battles staged in flooded amphitheaters. For centuries, historians dismissed them as exaggerated tales. But hydrological studies of the Colosseum and Domitian's Stadium have revealed intricate underground channels and sluices capable of filling and draining massive basins in minutes. With carefully balanced cisterns and gravity-fed reservoirs, engineers could transform a dry arena into a miniature lake and then back again using purely mechanical systems. No pumps, no electricity, only stone, pressure, and mathematics. Recent discoveries at Portus, the massive imperial harbor near Rome, add another layer to this technological narrative. Underwater archaeology there has exposed remains of breakwaters, constructed from hydraulic concrete, a material that hardened underwater. When samples were analyzed in modern laboratories, scientists found that the secret ingredient was volcanic ash, rich in philipsite and aluminum tobermorite crystals, compounds that grow stronger with time, not weaker. 2,000 years later, these submerged piers still hold together. The lesson is startling. While modern concrete decays, Roman concrete evolves. The Roman watermills of Barbigel, near Arles in southern France, stand as another rediscovered wonder. Once thought to be simple grain mills, the site turned out to be an industrial complex of 16 water wheels arranged in cascading terraces, one of the world's earliest examples of mechanized mass production. Recent analysis by the University of Cambridge found that these mills could grind enough flour daily to feed a city of 80,000. Arrangement demonstrates a deep understanding of hydraulic, gradients, and rotational mechanics. This wasn't random ingenuity. It was systemized engineering, what modern historians now call the Industrial Revolution of antiquity. Even more fascinating is the rediscovery of Roman climate control and architecture for airflow. The villas of Herculaneum, Pompeii, and Oplontis show evidence of air channels, roof vents, and porous bricks that moderated indoor temperature. Modern thermal simulations reveal these were intentional features, early examples of passive cooling systems. By aligning openings to prevailing winds and designing inner courtyards to act as pressure stabilizers, Roman architects created natural air conditioning centuries before electricity. Beyond stone and water, The Romans also wielded an uncanny understanding of metallurgy. Roman blacksmiths could produce steel through a process now called carburization, heating iron in contact with carbon. Swords from Vindonissa and Pompeii exhibit microstructures remarkably similar to modern high-carbon steel. Chemical analysis indicates that Roman smiths knew to quench blades in oil rather than water to prevent brittleness. This metallurgical sophistication directly contributed to the durability of their weapons, tools, and even surgical instruments. Meanwhile, Roman mining technology demonstrated an understanding of mechanics, chemistry, and hydraulics. In Spain's Las Medulas mines, remnants of channels stretching for miles show how engineers redirected rivers to strip away entire mountainsides in a technique known as ruina montium, the collapse of the mountains. By studying sediment deposits and soil erosion patterns, geologists have confirmed that this was one of the earliest and most effective examples of hydraulic mining. Though destructive, it showcased Rome's ability to harness nature's forces with precision and intent. Another forgotten technology rediscovered through archaeology is Roman timekeeping. Sundials, water clocks, and even portable timepieces made of bronze have been unearthed in multiple cities. One found in Aquileia was so precise that its markings matched modern calculations of solar time for that latitude. Scientists believe the Romans adjusted their clocks seasonally, accounting for daylight variation, a concept that mirrors the logic behind our daylight saving systems today. Modern excavations also reveal the Romans' mastery of optics and magnification. Fragments of polished rock crystal lenses discovered in Germany and Italy suggest they may have been used for magnifying small objects or aiding vision. This discovery challenges the long-held assumption that optical science began in the Middle Ages. The Romans, though they lacked the mathematical theory of light, clearly understood its practical applications. Perhaps one of the most mysterious rediscoveries comes from Antikythera and Herculaneum, where carbonized scrolls and fragments of gears have reignited debates about lost Roman computational devices. Though the Antikythera mechanism is Greek, later Roman writers described similar mechanical calendars and planetary instruments, suggesting that knowledge of mechanical computation persisted within the empire. When modern imaging scanned those artifacts, the intricate precision of their cogs proved beyond question that ancient engineers could translate astronomical mathematics into moving mechanisms. And then there is Roman urban infrastructure, recently re-examined through LiDAR scans across Europe and the Middle East. Beneath forests and fields lie the remnants of city grids, subterranean drains, and roads perfectly aligned to magnetic north. This rediscovery has forced historians to admit that Roman city planning wasn't improvised. It followed geometric rules that harmonized architecture with celestial and environmental factors. It is no exaggeration to call it an early form of data-driven urbanism. The rediscovery of these technologies through science, imaging, and excavation paints a portrait not of a crude ancient empire, but of a civilization rooted in experimentation, repeatability, and improvement, the very pillars of modern science. Rome's engineers, though working without electricity or engines, mastered principles that underpin mechanical, civil, and chemical engineering today. Each rediscovered device, pigment, or alloy adds another brushstroke to the same realization. The Roman Empire's true monument wasn't the Colosseum or the aqueducts. It was the knowledge system that built them. A system that merged art with practicality, faith with physics, and ambition with measurement. Their world has long crumbled, yet their blueprints, buried in ruins and volcanic ash, continue to shape ours. Whispering a truth we've only begun to understand, that progress, even in its most forgotten form, never truly dies. The technological genius of ancient Rome did not vanish with its collapse. It quietly seeped into the foundations of modern civilization. Roads built with layered stones, gravel, and concrete became the prototype for the world's first highways. The Roman concept of valle inspired later European and British infrastructure, whose roots often still trace those ancient paths. Every modern road network, from London to Istanbul, carries the invisible legacy of Roman engineering beneath its asphalt. The Roman aqueduct system became the blueprint for modern plumbing and urban sanitation. Engineers today still study the gradients and pressure balance of aqueducts like those of Inchiams and Segovia to understand efficient water delivery. Their use of lead and terracotta pipes marked the first step toward the integrated water supply systems that keep modern cities alive. In essence, every facet turned on today owes its design logic to Roman hands. Roman innovations in architecture continue to define the language of modern design. The widespread use of arches, domes, and vaults revolutionized how weight and space were managed. The Pantheon's dome, still the world's largest unreinforced concrete dome, inspired architects from the Renaissance to the U.S. Capitol dome. Even skyscrapers echo the Roman principle of structural harmony, balancing beauty with function through geometry and proportion. Their discovery of concrete remains one of history's most influential breakthroughs. Modern engineers studying Roman concrete have used its self-healing mechanisms to develop eco-friendly materials resistant to time and corrosion. Projects in marine construction now replicate the same volcanic lime formula that allowed Roman harbors to endure for 2 millennia. The Romans, without knowing it, pioneered a material science that modern sustainability movements have only recently begun to understand. The hypocaust system of heating became the ancestor of central heating in modern buildings. By channeling hot air beneath floors and walls, the Romans achieved temperature control unmatched for centuries. Today's radiant floor heating and HVAC systems follow the same logic. Controlled distribution of warmth through circulating air and thermal layering. Roman comfort technology set the precedent for the modern idea of engineered living spaces. In the realm of urban planning, the Roman grid layout influenced the organization of countless modern cities. Their meticulous division of space, public forums, markets, bathhouses, and administrative centers became the model for Western civic design. From New York's rectangular streets to Paris's boulevards, echoes of Roman geometry continue to shape how people move, gather, and live in urban environments. The Roman military's engineering discipline also transformed future warfare and logistics. Their precise fort construction, road systems, and supply chains became the standard for modern armies. Concepts like prefabrication, modular fortifications, and transport efficiency were adopted centuries later by European empires. Even today, Military engineering corps study Roman methods for field fortifications and bridge building. Roman advances in hydraulics and mechanics foreshadowed the machinery of the Industrial Revolution. Their watermills at Barbigel demonstrated mass production powered entirely by nature. Modern engineers see them as the first automated factories, precursors to water-powered textile mills of the 18th century. Through these innovations, the Romans laid the mechanical foundation for automation long before electricity existed. In public architecture, their amphitheaters and bathhouses set the tone for modern arenas, theaters, and spas. The design of stadium seating, acoustic optimization, and crowd flow in modern venues mirrors Roman understanding of spatial psychology. The Colosseum's tiered arrangement, entrances, and exits remain a direct ancestor of today's sports architecture. The very idea of entertainment as civic spectacle traces its lineage back to Roman design. Even Roman law and administration integrated technology into governance. Their meticulous record-keeping, inscriptions, and surveying methods paved the way for bureaucratic systems dependent on measurement and documentation. Modern land registry, taxation systems, and census taking all descend from Roman administrative technology, a blend of engineering and empire. In medicine and public health, Roman hygiene innovations reshaped how societies viewed cleanliness and disease prevention. Public baths, sewer systems, and water management reflected an understanding of health through environment. This concept evolved into the sanitation systems of modern Europe and beyond. The Romans not only built cities, but made them livable, a feat few civilizations achieved before them. Even modern architecture's artistic ideals carry Rome's fingerprints. From the Renaissance revival of Vitruvius's De Architectura to neoclassical monuments in Washington, Langdon, and Berlin, Roman design remains a visual language of power and stability. Each column and dome stands as both homage and continuation, a silent dialogue between marble antiquity and modern steel. Ultimately, the influence of Roman technology is not just in the things we build, but in how we think about building. They transformed engineering into philosophy, the belief that human design can tame nature, improve comfort, and preserve legacy. The Romans may have fallen, but their technologies became civilization's blueprint, ensuring that every modern innovation still carries a spark of the ancient flame that once illuminated the eternal city. The Roman obsession with precision and measurement continues to define modern science and engineering. They were among the first to standardize tools and measurements across an empire that spanned continents. The Roman gramma, a simple yet ingenious surveying instrument, allowed for the creation of perfectly straight roads and uniformly planned cities. This concept of standardized measurement evolved into the modern metric and architectural systems used today. Engineers and builders in the Renaissance and Enlightenment eras directly referenced Roman surveying principles as they reimagined Europe's urban landscape. The Romans' approach to transportation and logistics reshaped the movement of goods and people in ways that mirror our global networks today. Their intricate web of 400,000 kilometers of roads connected not just cities, but economies, ideas, and armies. These routes became the arteries of empire, and later the blueprint for European trade routes, postal systems, and railway networks. The notion of a unified transport grid, so vital to global commerce now, was first realized through Roman road engineering, which made travel efficient and communication nearly instantaneous for its time. Roman bridges and viaducts further embodied their mastery of applied geometry and materials science. Structures like the Pont du Gard in France and the Alcantara Bridge in Spain are not only marvels of endurance, but also prototypes for modern civil engineering. The use of keystone arches to distribute weight efficiently laid the groundwork for bridge building, techniques that remained unchanged for centuries. Even in the 21st century, bridge designers reference Roman structural ratios for stability and aesthetic symmetry. Their achievements in maritime technology also anticipated many developments of the modern naval world. The Romans engineered ports with breakwaters designed to calm storm surges, principles that modern harbors still apply. Their ships used a combination of wind and/or propulsion, hull reinforcement, and navigation based on stellar charts. In some ways, the Roman mastery of sea logistics foreshadowed the global trade routes managed by container ships today. Maritime archaeologists studying Roman wrecks have found advanced bilge systems and watertight compartments, revealing a sophistication centuries ahead of its time. In communication and information networks, the Romans laid the foundations of what we might call analog internet. They established the cursus publicus, an organized postal system run by the state, where couriers relayed messages across the empire via relay stations and fresh horses. This model of systematic communication inspired later empires, including the British and Ottoman systems, and eventually informed the design of modern postal and telegraph services. The speed, accuracy, and administrative control of Roman communication represented one of humanity's earliest experiments in global information management. Roman innovations also influenced the development of law enforcement and public order systems. Their engineering of urban infrastructure, such as lighting, paved streets, and gated forums, supported organized policing and night patrols. The modern concepts of civic security, traffic regulation, and public responsibility trace back to Roman ideals of order through design. Their emphasis on spatial organization was not merely aesthetic, it was deeply social and political, ensuring stability through structure. The Roman agricultural revolution quietly transformed humanity's relationship with the land. Innovations like water-lifting wheels, crop rotation techniques, and advanced plowing tools enabled more efficient food production across vast territories. The widespread use of mills powered by animals, wind, and water turned agriculture into a mechanized system. These techniques resurfaced during the medieval period and formed the foundation of modern agricultural mechanization, feeding populations at unprecedented scales. Even in medicine and public health, Roman engineering played a defining role. The construction of valetudinaria, military hospitals, introduced standardized healthcare facilities with ventilation, sanitation, and patient segregation. These concepts evolved into the design of modern hospitals. Their understanding of clean water, waste removal, and physical hygiene became the model for 19th century public health reforms in Europe. In many ways, Rome's approach to health infrastructure was more advanced than much of the medieval world that followed. Roman mechanical ingenuity also left its fingerprints on the birth of modern machinery. They created complex devices, such as the odometer, used for measuring distance on roads, and the automata, mechanical figures that mimicked human or animal movements. These inventions inspired Renaissance thinkers like Leonardo da Vinci, whose mechanical sketches often mirrored Roman design logic. The Roman fascination with motion, gears, and water pressure laid the conceptual groundwork for industrial mechanics. In the realm of education and engineering philosophy, the Romans established the world's first institutions for technical learning. Their guilds of architects and builders, known as Collegia Fabrarum, served as early engineering academies. Knowledge transmission through apprenticeships and written treatises created a professional culture of design excellence that later influenced the foundation of universities and technical schools. This intellectual continuity, from Roman masons to modern engineers, demonstrates how ideas outlive empires. Even Roman art and sculpture influenced modern industrial design. Their mastery of proportion, symmetry, and form became central to European art and architecture for centuries. When industrial designers began shaping machinery, vehicles, and even city skylines, they unconsciously drew upon Roman aesthetic values, the harmony between form and function. The clean lines and balanced proportions seen in modern architecture can be traced back to the same Vitruvian ideals that guided Roman builders. One cannot overlook the Roman legal and infrastructural vision that shaped Western governance. The codification of laws, property rights, and urban planning regulations established the framework for modern bureaucratic states. The Roman belief that infrastructure served not just rulers but the public good continues to underpin modern civic planning. Their idea of civitas, the city as a living organism, remains a guiding philosophy for urban development and public administration today. The Roman spirit of innovation was not merely technological, it was deeply philosophical. They viewed invention as a duty to civilization, a belief that progress was a public service, not a private luxury. This mindset, inherited through the Renaissance and Enlightenment, still drives modern innovation. Whether in bridges, medicine, or digital networks, the Roman legacy endures not as relics of stone, but as living ideas embedded in every human endeavor that seeks to connect, build, and endure. The more historians and engineers uncover about Roman achievements, the clearer it becomes that their influence never truly ended. Every road we pave, every city we design, and every technological system we construct is, in spirit, an extension of the Roman world, a continuation of their dream to bind humanity through invention and order. As we reach the end of our journey through the ingenuity of the Roman Empire, it's impossible not to feel a quiet awe at the scope of their accomplishments. Roads that stretched like veins across continents, aqueducts that carried life-sustaining water to bustling cities, and innovations that bridged the gap between practicality and art. These were products of a civilization that valued order, precision, and vision. The Romans remind us that technology is not just about gadgets or machines. It is about creating structures that endure, systems that connect people, and ideas that outlast empires. Even centuries later, the principles they established continue to shape our world. Modern engineers still study Roman aqueducts to understand water flow. Architects echo Roman proportions in contemporary buildings. Urban planners draw inspiration from the careful layout of Roman streets and forums. Every time we step onto a paved road, walk through a well-organized city, or marvel at a functioning bridge, we are touching the legacy of Rome, consciously or unconsciously. What is most remarkable, perhaps, is that this legacy was born not just from brilliance, but from a mindset, a belief that human ingenuity, when applied thoughtfully and methodically, could serve society for generations. Rome's technology was not fleeting. It was a gift to the future, quietly teaching the world how to combine creativity, resilience, and practicality. As you reflect on these ancient innovations, consider this: the world you inhabit today is, in part, a continuation of their experiments, trials, and successes. The spirit of Roman technology lives in the water systems that sustain us, the roads that connect us, and the buildings that shelter us. Their inventions, long silent and buried beneath layers of time, still whisper lessons about endurance, vision, and the subtle art of improving everyday life. So, as you drift into your own thoughts, or perhaps even to sleep, remember that every small structure, every simple machine, and every thoughtful design in your world carries the echoes of Rome. And if this glimpse into the past intrigued you, the next story we explore will take you even deeper into the hidden, astonishing realities of history, reminding us that the past is far richer, stranger, and more fascinating than we ever imagined.